All right, so for example, number one, 12,000. So we don't have to write all the zeros out. Now, relatively speaking, 12,000 is not that big of a number. All right, but it still can be written in scientific notation. So I need everybody to understand the decimal for 12,000 is at the end. I think everybody knows that. All right. Now, to write in scientific notation, you want your decimal after the first non-zero digit. So we are going to move it from here after the 1. All right. So I want everybody to write down. Well, you don't have to. Just look at this for a second. 1.2000. Now, is it necessary for me to put 000 in? No, because zeros at the end of a decimal don't change the value of the number. So we just write 1.2. After we write 1.2, we say it's times 10. All right, times 10. It's always going to be times 10. The reason why it's going to be times 10 is because that's the number system. I don't know if you remember this, but in second and third grade, they talked about the Dewey Decimal System. All right, we're just in powers of 10, believe it or not. All numbers can be written as powers of 10. So it's 1.2 times 10. Your objective is to count how many places did you move the decimal. So if I moved it once, twice, 3 times, and what? 4 times. That's all there is to it. So this would be considered 1.2 times 10 to the what? Times 10 to the 4th. All right, I moved it 4 spots. All right. That's what we're doing. Did I count the zeros? No, come on, Luca, you're super smart. All right, I'm trying to get you to learn and make some observations on your own. Do you see what I'm saying? How many zeros are there?
3.
Does that correspond to the exponent? No, does not. Sometimes does it? Yes, not always. All right, so let's take a look at number 2. All right, now I have 130,000. All right, if I have 130,000, the decimal is right here. I move it. How many places? 5 spots. That's exactly right. So it's just 1.3 times 10 to the what power? That's it. That's all there is, guys. 1.3 times 10 to the 5th. All right. Again, is it the number of zeros? No, it's not the number of zeros. All right. What?
So we don't solve these?
We're writing them in scientific notation. All right. We're writing them in scientific notation. We're really not solving anything at the moment. All right. We're changing the form. All right. So if I look at, so does anybody know what that number is? 21 what? I think it's 21 billion. All right. 21 billion. All right. So once again, we just write 2.1 times 10. Now, again, I like to tell kids the commas separate them in groups of what? 3. So I like to just say 3, 6, 9, 10. 2.1 times 10 to the 10th. All right, we don't want to write all those zeros out. All right, anybody have any questions with that? Pretty good, Kellen, so far, man. All right, I'm watching close. All right, and I mean it all the way back to what I said last. Just because it's a new week doesn't mean there's new rules. Andrew, same with you. Leave them alone. All right, here we go. Number 4. Now you're supposed to recognize these are just what? Decimals. All right, for whatever reason, I don't understand what this causes problems for kids. All right, the rules don't change. All right, I need the decimal after the first non-zero digit. Now, does everybody understand 5 is not 0, correct?
Mhm.
So it has to go after the first non-zero digit. 5 is the first non-zero digit. Do we agree?
Mhm.
So the decimal goes 5.0. All right, 5.0. Now, do I technically have to put 0.0?
Mhm.
No, but I'm just showing you. Now, 5.0 times 10. Now, how many places did I move it? 3. 1, 2, 3 decimal places. So it's going to be to what power? Who is listening? Thank you very much for listening. It's -3. All right. All of the decimals are small, so they require what? Negatives. The big numbers are big, so they require positives. All right. We just don't put positive down. All right. So everybody take a quick look at number 5. All right. Put what you think the answer is. 8 times 10. Now, how many places? Kind of annoying to count the decimals because there's no common. How many? Let me see if she's right. 1, 2, 3, 4, 5, 6. That's how easy. 8 times 10 to the -6. Anybody have any issues with that? All right, now let's look at number 6. 0.000234. So everybody write what that answer is. Kellen, what did you get?
I got 2.34.
Exactly. You have to write out the numbers if they're not zeros. And then how many places did you move it?
Uh, 10 to the -2.
That's exactly right. Thank you for listening. All right. 2.34 times 10 to the -4. Anybody have any questions with that? All right, everybody's got to stop what you're doing now because you're brilliant. We're going to stop for a second. I don't want you writing all the answers yet. Luca, did you have a problem?
So we're gonna write 3 numbers, you go to the first one.
Yes, that's exactly what I mean by the first non-zero number. The first number that's not a 0. Good job. All right, now I'd like everybody to scroll down because I think we're smart. Scroll down to number 25. All right, now these numbers are written in what? Standard form. All right, or I'm sorry, these are written in scientific notation. We want to write them in standard form. Or I want to write them in standard form. So this right here times 10 to the 4th. What does that mean I have to do to the decimal? I need to move it what? 4 places where? To the right. And the reason I know it's going to the right is because I want the number to be big. If I move it to the left, the number's getting what? Small, because that's a decimal. So I take 9. Sometimes I want to do this, 9. How many places do I have to move it? Come on, what? All right, here's a decimal. Now, how many places do I have to move it? 4. So how many zeros do I need to add?
Right? No, or because it's to the right.
That's exactly right. He's exactly right. I have to move it to the right. So if you want, I used to do this. 1, 2, 3, 4. The decimal would be there. And then I would just add in the zeros. All right. Now, I don't think you guys need that. I think you just need to say, okay, I'm moving it to the right 4. So if I'm moving it to the right 4, I need to add how many zeros? 4 zeros. Everybody, if you're paying attention, should be able to do that. So if I add 4 zeros, what number is that? Yes, 90K, or right, 90,000. All right, now we're going to look at 26. I need to move the decimal how many places? 7 places. Now you're paying attention. How many zeros do I need? 6. Why do I only need 6 this time? Because there's a 0.2, that's already one spot. So I need to write 72 down, and then how many zeros? 6 zeros. 1, 2, 3, 4, 5, 6. Then you're expected to go back and put the commas in. So this is what number? 72 million. All right, it's 72 million. All right, now I'm on 27. 3.98 times 10 to the 6. How many zeros do I need to add? 4. So everybody's writing down 3, 9, 8. 1, 2, 3, 4. And then tell me what number this is.
3,980,000.
Yeah, everybody should be able to say numbers, the big numbers and the small numbers. 3,980,000. All right, now the decimals are always harder for kids to say. All right, so questions 28, 29, and 30 are harder for kids to say. I would like you to be able to say what a decimal is. All right, so let's take a look at this number right here. How many places do I have to move the decimal?
7.
How many places do I have to move the decimal? Wow, I don't. 6. Yeah, the exponent is the number of places you're moving the decimal. I'm moving it 6 places. In what direction? To the left. So how many zeros do I need in front of the number? 5. The reason I don't need 6 is because I'm moving it once already. That counts for one of the spots. Is everybody with me on this? Now, I promise you it's super easy if you're listening. So how many zeros do I need in front? 5 zeros. 1, 2, 3, 4, 5, and then I need the number 37 with a decimal out in front. All right, now does anybody know what this number is? Can anybody say it? Thank you.
7 million.
37 millionths. I don't know. I haven't checked yet, but that's a good guess. Anybody else want to give it a shot? What do you think it is? No, I'm asking what the number is. All right, that's what I'm interested in. Hunter, what's the name of the number?
7.3 million.
No. It can't. It has to be 37. The number here is 37. So it's 37 hundredths, 37 thousandths, 37 ten thousandths. I'm not sure. So we're going to remind you the decimal places. So here we go. The first spot, the first spot is the what? Tenths. That's the tenths. This is the what? Hundredths. This is the what? Thousandths. This is the 10,000ths. Next. And the next. 10 millionths. So this number is 37 10 millionths. All right, now I'm not expecting you to write that down. You don't have to write it down. I would just like you to be able to know the number, right? I don't want you to say 0.000037. All right. I'd like you to say that's 37 10 millionths. All right. Now I know you know your number system. What?
Can you go back to that one that you said for being?
What? Come on, what?
Why did you do that?
Come on, Luca, you got to speak up. Come on. How many places do I move the decimal, Luca? 1, 2, 4 zeros. You with me?
Yeah.
All right, let's look at 26. How many places do I move the decimal, Luca? Look at 26. How many places do I move the decimal? So how many zeros do I need? There you have it.
I think that you should be able to treat this.
All right, here we go. 29. Here we go. How many places do I move the decimal, guys? 3 places where? To the left. All right, so if I move it 3 places to the left, how many zeros do I need? 2, 3 or 2? 2.0096. Now I'm expecting everybody to be able to tell me that number. And at the beginning of this class, some of you didn't know how to name decimals. All right, which is what you did, I think, in 3rd grade. All right, so I know it's been a long time. All right, so when you take your ERBs, you're going to know decimals this year. All right. Now we don't say 96 to the, because that makes it sound like it's an exponent. All right, so I don't know. So I'm asking tenths. Then next is hundreds, thousandths, 10,000ths. Every time I count it, every single time. So he's correct. That's 96 what? 10,000ths. And remember, it has a THS at the end. That signifies that it's a decimal. All right, so let's check out 30. How many places do I move the decimal? 4 spots. So I need how many? 3 decimals or 3 zeros. Decimal 1, 2, 3, 88. All right, so somebody please calculate that for me. 88 hundred thousandths, tenths, hundreds, thousands, 10,000, 100,000. So she is correct. All right, does anybody have any questions with that? Anybody? All right, here we go. So I'm going to scroll down the page. All right, now for some reason, these are the ERB type questions where you have to write the numbers in order from least to greatest. From least to greatest. All right, so I want everybody to just put your eyes up on the board because this is something definitely that can be improved. All right, it's hard for me to teach you algebra if you don't understand numbers. Everybody understand why I'm making sure you're hearing me? All right, so if this is 10 to the 4th, if this is 10 to the 4th, is this 10 to the 4th, and that's 10 to the 4th, does that really even matter? No, they're all 10 to the 4th. So really, all we're doing is we're just comparing what? These what? These numbers right here. That's what we're looking at. I said smallest. So remember, when you're looking at decimals, come on, guys, don't think you know. Please listen, because most people forgot. Can we tell which number's bigger by looking at the 4? No. So now I've got to look to the next number. 6, 5, 6, 5. So which two are the smallest? Now we're going to say the first, second, third, and fourth. Which numbers are smaller? Second and fourth are smaller than first and third because they have a 5. Then you look at the next number. This number is a 1. This number is a 1. So they're still the same. Do we agree? Now, after this 1, we could put a what? 0. So this is a 0. This is a what? So which one's smaller? The first, second, third, or fourth? The second is the absolute smallest. Now, am I okay writing a 2 down? Yes, I should make you write the whole number, but because I know you're smart and you understand, you can put number what? 2 down. Then what's the next smallest? 4 would be the next smallest. All right. So now I'm going to cross out 2 and cross out 4. Now, which one is the smallest from 4.6 and 4.651? The first one is, right? Because it's a 6 and a 6, but the next number is a what? 0, and you're comparing that to a what? 5. So it's 2, 4, then a what? 1, then a what? 3. All right, there we have it. Everybody good with that? All right, so now I want to take a look at something that might be more challenging. Let's look at 60. Now, to me, we should either write them all as scientific notation or we should write them all as numbers in standard form. In this case, I like to write in standard form. I think it's easier. Hopefully you agree with that. So how many places do I need to move the decimal here? 4 spots. So that's going to be how many zeros? It's negative 4, 6, 1, 2, 3. Anybody have a problem with that? Negative 4.1 times 10 to the 4th. How many places do I move the decimal? How many zeros? So that's going to be negative 4, 1, 1, 2, 3. And now I have negative 419,000 and negative 420,001. All right. So now, does everybody agree we're doing negatives? Right? So everybody should be able to look at that and say the largest negative is the what? Smallest. All right, now, like I said, I don't understand why kids have trouble comparing numbers. That's why if you're sitting there going, man, the guy's crazy, I have no idea what he's talking about, I need you to speak up now. All right, I can't teach you algebra if you don't understand numbers. All right, so everybody's looking at this right here. All right, so which one is the absolute smallest number? Now, number 4, yes, because that's negative 420,000. So 4, then what number? 3, then what number? And then what? Yeah, they're trying to trick you here by putting different sizes, right? This is 41,000 and this is 46,000. So everybody agree with me on that? Now, does everybody see how easy it is to make a mistake? Right? It's easy to make a mistake. All right. Now, just to be sure, I want to look at 58. We're going to do 58 together, then I'm going to let you do it on your own. Well, hold up. Someone said, while everybody's working on 58, I'm going to help Luca with 60. What's the matter, Luca? Would you rather owe me 420,000 or 46,000? You'd rather owe me 420,000 than 46,000. On a number line, Luca, come on, buddy. On a number line. Here's 0. The first number, if I'm going in this direction, right? Negative 46,000 is right here. Negative 420 is way on down the road. Negative 420,001. That's way over there. Do you agree with that? That's why that's smaller. You agree or not? Okay. Let's talk about 58 now. I got some decimals here, which is somewhat annoying. Now you have to decide, would you rather write them in standard form or decimal form or in scientific notation? Doesn't matter to me. All right, but let's look. I like standard form personally. So I have to move this decimal how many places for the second one? 5. So how many zeros do I need? 4 zeros. So 1, 2, 3, 4, 4, 5, 1. On the third one, how many zeros do I need? 5. Thank you very much. 1, 2, 3, 4, 5, 2, 6, 5, 1. There we go. Those are your numbers. Now, I think it's obvious. All right, but let's look. I need to count here. 1, 2, 3, 4, 5, 6, 7. There's 7 zeros, correct? Over here, 1, 2, 3, 4, 5, 6, 7 zeros. Does everybody agree? Over here, there's not 7 zeros. 1, 2, 3, 4. 1, 2, 3, 4, 5. So which one's the smallest number? Whoa, whoa, this is what I'm talking about. This is what I'm talking about. One is the what? One is the smallest, right? 0.00, because remember, these numbers over here are going to be zeros. Does everybody agree with that? Hello, is everybody with me now?
Yeah.
Right? So the smallest one is what? 1. The next smallest would be 4. I like that. Now, the next smallest number, 3. And then what?
2.
And does everybody see how most people look at the 4 and the 2 and they say 4 is greater than 2, but that has nothing to do with it, correct? It has to do with the spot of the 0 and the number. Am I making sense, Luca? Okay, just checking. You good? All right. So I'm okay with you writing 1, 4, 3, 2. Does everybody agree with this? All right, now these require some thought and some time. All right, these right here, you got to be careful. That's really the most important part of the lesson, though. This stuff up here should be relatively what? Easy. It's just moving decimals. All right, everybody think we're good? All right, I'm happy with that. All right, so please finish up. If you're still a little iffy, you can come see me and I'll be happy to help you. Of course, go. Bless you.